Welcome everyone to Automation in Action, accelerating your FME Flow deployment with CI/CD. Today we are joined by both Dami and Merlin as our presenters. And I'll hand things over to Dami to introduce himself first.
Yeah, my name is Dami, part of the FME Flow team, and yeah, looking forward to discussing more CI/CD with you today and how that works in FME.
Fantastic. And Merlin.
Hi, everyone. My name is Merlin George. I work with Dami in the Flow support team, and here today to share with you some of our findings on our CI/CD workflow.
Fantastic. All right, so just briefly here before we dive into today's content, I want to go over a few pointers with our platform. So if you have any audio or video issues during the webinar, we do have that help button on the bottom left you'll see, and you can click that for 4 simple steps to take. Share your emoji reactions with us during the webinar. Those absolutely fuel us. We love to see how you are reacting to the content as we go along. So please do make use of that button. We love to see those reactions come in. And questions. If you have any questions for our presenters as we go along here, please make use of that questions tab. Now we will have some time dedicated at the end to answer questions live, but we should also be able to keep an eye on that and get to some during the webinar as well. So please don't be shy and drop your questions as we go. The chat, keep letting us know where you're tuning in from there and leave any comments during the webinar. So at this point, I will prompt our presenters if they can turn off their webcams, just to save on some bandwidth for the remainder here. And I will pass things over to Dami for our agenda.
Yeah, so thank you very much, Elizabeth. For our agenda today, we'll be looking into what is CI/CD, kind of give like a brief overview on that, and also why use CI/CD with FME. We'll also touch on the applications used for experimentation and for our own use case scenario that we'll be going through in this presentation. And also we'll look at more Jenkins demos, how all of those have been configured, what we did, and the results. From there, we'll look at the resources, next steps, and other questions and answers that you might have. We'll be more than happy to help. Most of the challenges, I would say, overall, that the individuals have had is how they can get it done even faster, how they can automate their processes without having to, touch so many of those components, reduce the possibilities or the likelihoods of any human errors, and also to ensure they have more of a standard way of deploying FME. So overall, the speed of deploying, automating some of those functions, especially some of the configurations you have once FME is deployed, upgrading FME generally, and then backing up and restoring of your previous versions and ensuring that that process is repeatable to FME could easily get started. So what are the prerequisites, some of the things we're going to be looking at to ensure you have on your system? In this case, we'll need a cloud provider, and in our case, we're using AWS. And whichever cloud provider you're going to be using, you will need permissions into that particular console, that system. You need access to Jenkins, you need to install Terraform, and you need GitHub access or IEC template. So to give more details into that, we'll be talking more about how all those sections work and the actual connection between all those tools and all those components. In our case, we're going to be using Jenkins, Terraform, AWS, and GitHub primarily as our focus tools. And in this article, we'll be exploring how they are connected, how they work to create a perfect, I would say, very close to perfect CI/CD workflow for you to deploy FME and address some of those challenges we previously touched on. So we've been talking about CI/CD for a bit, so how about we just look more into what that actual concept is. So CI/CD basically stands for continuous integration and continuous deployment, with the main aim of accelerating the overall software development lifecycle. In this case, is basically continuous integration is basically getting into the code itself, making changes on that code, and then continuous deployment is pushing some of those changes or pushing those changes you've made in continuous integration, pushing those changes into your deployment environment, whether that's production or dev environment. In the case for FME, it's making changes to the IEC templates previously touched on. IEC templates will be stored in GitHub, which is what I also mentioned as well, and using Terraform, which will be the content of what's in the IEC template of your deployment. And then Jenkins serves as that driver, which is doing the continuous deployment. And then AWS will be the deployment target in this particular case. So just giving a high-level overview of why we needed those prerequisites and how that ties into what CI/CD is. To also give a broad overview of FME, FME Form, which is basically the desktop version of FME, FME Flow, which is the server version, also FME Flow hosted, which we have as more of a backend hosted option for FME, where you don't have to provision the actual infrastructure yourself. And then FME Realize, which is an AR offering for FME. And we have multiple data types that we support and different ways you can use FME, indoor mapping, graph, AR, VR, point cloud, raster. So with other more than 500 different data types that we support in FME. So just to give you kind of a high-level overview of how powerful the actual application is and what's required to actually successfully deploy it as well. So why use CI/CD with FME? So upgrading time, as we mentioned, it can be complicated to upgrade certain deployments of FME based off the kind of environment or the internal policy that you've set up in your organization. So overall, there are multiple deployment types for FME, which is the express, distributed, and you have the fault-tolerant setup. You could also install with remote engines, and they get complex over time depending on your use case. So with CI/CD, you only need to know what version you're upgrading to once you have had that first deployment done. So once you've set up your CI/CD, if you wanted to upgrade your version of FME, without CI/CD, you would have to go into your actual configuration, check to see, okay, do I need to like use this property here? Do I need to back up something here? Do I need to restore something here? Do I need to update like a DNS this sort of way? And if someone's new, they might not have all that information quite readily available. That's even in your own organization compared to someone who did the first deployment of FME. So that saves you time because once you've done the CI/CD deployment, you just need to go to your variables, input some of those information that we just mentioned, like maybe the version of FME you're upgrading to, the DNS, and other interesting variables that you can consider when upgrading, like things like to consider like your backups and other information like that. So this also ties into the second point. If you were in a situation where a user, for some reason, if a user, someone that hasn't had any experience with FME strongly, were to go into the system, they might be confused in terms of upgrading FME without CI/CD. They might be a bit confused to knowing the process. But if they have some knowledge of Jenkins and with simple playbook instructions like click this button, input this version, fill this out, next, they're done with the most complex deployment you can think of in FME, as long as it's already been provisioned the first time. So a new user can get into deploying FME with CI/CD by ensuring those steps are repeatable. And yeah, so that would be one of the benefits of using CI/CD generally as well. The ease of deployment, which was also touched on, it makes it easy as long as the first pipeline has been configured. User can just go there with a few clicks and they're done. Yeah, and also reduces the amount of errors that you have with your configuration because everything will be standardized. Then enhanced configurability as well. So you can be more flexible with how you do your configurations for your deployment from firewall rules, network infrastructure, and you can also use multiple cloud providers, which is also a major benefit of using CI/CD. And just using like an example, if you had like a proper CI/CD pipeline configured, you've deployed FME in the past, and you wanted to, change some things like, oh, my firewall, like deployment targets, if I wanted it to be dev, if I wanted it to be prod, if I wanted to adjust something just based off any sort of like requirement that might be unique to my situation, I can go into my Terraform files, make the changes in GitHub, in that case, complete that change, then all of that's going to be propagated and it's going to be standardized in the future deployments of FME that I'll be moving forward. And you can configure it even more flexibly than if you were with the out-of-the-box FME deployment, because you have access to the actual other components in the form of IAC, which is infrastructure as code in this particular case. So yeah, you can configure that even more flexibly than you would normally. So some of the applications we used in our own use case as well to test a CI/CD pipeline overall, and start first, would be Jenkins. So Jenkins is our central point of integration. So in the whole CI/CD vehicle, Jenkins stands as the man in the middle, the person that's taking from the continuous integration and saying, thank you, give me the code, and then it's pushing it out to where it's going to be deployed for the continuous deployment. So it's doing the continuous deployment, taken from the CI itself, which is GitHub, and then Jenkins is running that pipeline. Connects GitHub, like I mentioned, GitHub, Terraform, AWS, and FME. So it's connecting GitHub in the sense that it's reading the code from there. It's connecting Terraform in the sense that Terraform is stored in the GitHub repository where Jenkins is going to be pulling that from. AWS is the deployment target, and FME is the actual application that's written in the IAC form. Yeah. And overall, it's also cloud agnostic. So we could have tested this using Azure. So depending on if you're using Azure and AWS, you could use any one of the cloud providers as well. Not so sure about GCP as that now, but most supported will be AWS and Azure at this moment in time. It's also free and open source, which is why we also use this for our testing, because we believe most of our users, at least for testing purposes, you would rather just try it out on this system before you get into some sort of subscription and for just testing in the meantime. So yeah, and it's also pretty easy to set up. All the information is in their official documentation, should be also very straightforward. And yeah, the installation process, if anything, you can get on this link. We've also attached some articles which we would share at the end, showing more details, at least into some of those tools and the plugins we need. So overall, with Jenkins, we needed to install a bunch of other plugins. Those plugins, they include a variety. So these are just a few of them, at least 4 here. We also have other ones, the credentials binding, the pipeline utility plugin as well. Yeah, I'd say those are more of the important plugins, things to consider when installing Jenkins. Then GitHub acts as our repository source. So that's where we get access to the Terraform code that we utilize in the final deployment. So as mentioned earlier, when I was discussing how Jenkins connects with all the other tools, GitHub contains the IAC that we're going to be using to deploy FME. Because FME is going to be written in the Terraform formats, so all that code is going to be stored in GitHub. So that's where it's going to be pulling everything from. You can store changes, so any configurational changes that you make to the Terraform file that deploys FME is going to be stored in GitHub. You can collaborate with other teammates, and you can also receive contributions from other teammates as well. And Terraform, we've spoken a lot about Terraform and how FME is going to be written in Terraform. You retrieve everything from Terraform. So what is actually Terraform? Terraform is a cloud agnostic IAC tool that lets the users define their infrastructure as code. So that's basically letting the user the flexibility to configure how they want their actual underlying infrastructures to be deployed at that point. You write your entire infrastructure where you want FME to be deployed, which would include your network servers, which will also include your actual computing CPUs, which are your EC2s in the case of AWS, and also help you go through the hassle of making sure your security groups are correct, things like that, and connecting all the necessary resources to provision the infrastructure that you're going to be using to host FME. An example of what that looks like is here, where you can see Terraform, the provider is AWS in this particular case, the version, and you can see some of the resources that are going to be created in this particular module, where you can see network. All of these resources, ideally, or not, I would say in the past, at this point, you would go in the console, click, 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 create your VPC, click, 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 internet gateway, click, 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 VPC. But all of this, once it's written as code, you just press one button and all of that's deployed, or you just do a Terraform apply and all of that's deployed. So lots of time savings there. So the structure for how Terraform works is it stores everything in the state file, where your current infrastructure state and connects with different cloud providers. So all of that, just giving you a high-level overview of what that would look like as well. It's way more complex in its inner workings, but I would say for your use case or for anyone's use case, just trying to deploy FME, it's just mostly about understanding the IAC, which is already written in our IAC code in GitHub, and then you can just do the deployment. It's pretty straightforward, as we'll show later on today. AWS, just to give a bit more background, we've been mentioning AWS, cloud provider, AWS. So in this particular case, it's going to be giving us the server, storage, network, security services, all of that I mentioned when provisioning your resources with Terraform. AWS is that target where all those resources get created. If you wanted to use Azure, it's going to create the Azure equivalent of those same resources that were written in Terraform. And the setup for the actual CI/CD flow. So this is just a scenario. It doesn't have to apply to your case if you just wanted to do a simple deploy. This is just its own unique case sample. So let's say there's a team 1, team 2, team 3. Just to provide you more of an overview of how you could use IAC, you would firstly build the actual application. Then with the other software components which are part of the IAC, integrate that into the actual software itself. Jenkins runs the CD process here and then packages it and before you do your final deployment. So all of this can be configured in different multiple ways. There are some configurations where you could have up to 20 stages, 40 stages, all depends on you. The first stage could be build, second stage could be validate that build, the third stage could be deploy your image, fourth stage could be pull that image and use. All the ways you can configure it is really up to you. And we'll show you in our case how we did ours, just to give a good example of where to start and where to grow from. But yeah, this is just a typical setup. Build, integration testing, system testing, acceptance testing, and all of that could mean build my IAC image for FME, integrate that with the current workflow that I have, my CD process, and then maybe add like a testing stage to what's already been deployed. Here will be like the Terraform plan. And if you see here, the integration testing could be the Terraform plan. It's showing you, oh, this is what's going to be deployed. Then the apply can be, okay, delivery deployed. And then the acceptance testing would be like, okay, post-validation checks, post-installation checks, and things like that. Yeah, so another important thing is the AMI creation, which would help with, generally, it's your source of truth for your FME deploy. So everything FME is going to be installed in your image, and that image can be used in any installation that you wanted based off how you created that image. You could create it as an express or distributed, but that image contains your FME application itself. And when it's built and completed, it will look something like this, where it's saying build finished, the artifact is successful, and this was created, this AMI. When you deploy with this AMI, you deploy FME. And yeah, this is what it would look like in this particular case, where it was created in AWS. This is the platform, Microsoft, Windows, this particular case, and yeah. So some of the resources that's also going to create EC2, VPC, security group, the application load balancer, the AWS directory service, IAM role. So just giving kind of a high level overview of those resources that I already mentioned. Then the CLI, which is some other important components in FME to work properly in the CI/CD flow, is the FME Flow CLI, which uses the REST API, which interacts with the REST API to interact with FME Flow. So there'll be some commands when you're installing FME directly, where you have to click something, you have to choose something, you have to perform certain actions. The CLI kind of works the way it would, almost like a silent install, where it's like running some of those commands that do some of those operations in the backend for you when the CI/CD process is running. So usually it will be installed in a directory in Jenkins itself, and for you to be able to use that functionality, and for Jenkins to also look into that functionality and communicate with them overall. Another important thing generally is the FME API. So this provides pragmatic access to the FME functionality itself overall, and enables the integration with applications, generally custom applications and automation tools in the CI/CD pipeline. So if you're sending, receiving notifications, running jobs, managing user accounts, licensing FME Flow, things like that, these tasks that need to be done are all done using the FME API. And you can definitely leverage the API using different languages, create custom integration layers between FME. Generally, all of that in your own experimentation, you can also do that. But overall, the API is a very powerful tool to enable that communication. So thank you very much. We're going to be looking more into some of those examples using Jenkins, and I'm going to have my colleague Merlin help give you more of a practical overview of using the CI/CD process. Over to you, Merlin.
Thanks, Tommy, for covering the fundamentals of all the different components involved. Let's jump into the automation itself. We will be reviewing 4 Jenkins pipelines that could potentially be merged or chained together, with one pipeline triggered sequentially by the previous pipeline. That way you can have a completely automated deployment process. First, we go over the test environment to provide some context for this exercise. We have a Linux-based distributed Jenkins setup on AWS. So we have a controller VM that manages the jobs and agents, and then an agent VM that runs the jobs. We optionally also have an Nginx reverse proxy acting as a front endpoint. This is not mandatory, it's just best practice, but yeah. And then the type of job we are running on Jenkins is called a pipeline job, and we define a script on the pipeline. The script is written in what's called Jenkins declarative pipeline syntax, which means that it follows a structured block style and it has nested sections for better readability. The Jenkins scripts are based on a language called Groovy. And then within the script, we have shell commands, FME CLI commands, API calls. We've installed AWS CLI, Terraform, Packer, FME CLI, Git, and some required Jenkins plugin on the agent node, the one that's running the job. And this is a prerequisite that must be fulfilled. We've also added credentials on Jenkins for the AWS account for access. Same has been done for GitHub repo and also for the SSH connection between the 2 distributed Jenkins nodes. Now our first pipeline creates AMIs or machine images on AWS using Packer. Then these VM images will be used in our next pipeline when we deploy fault-tolerant FME Flow. We need 2 different AMIs here, one for the Flow core and one for the engine VM. So let's just look at the script for this. The first step here is declarations and definitions. The first directive ensures that the pipeline runs on the Jenkins agent node that has all the prerequisites installed, like the AWS CLI, Git, Packer, Terraform. As I mentioned earlier, we need all of these prerequisites. Next, we define all the user parameters that we provide values to at runtime. So we need the installer URL from our FME downloads page, a base VM image from AWS catalog, and we also add values for tagging purposes, like the AMI owner name, bill number. So this is all for tagging the new custom AMI that we'll be creating here. We also set the AWS region where the AMI will be built, so we have an environment level variable for that. Moving on to the pipeline stages within the script. We validate that none of the required parameters are empty and that the base AMI value has the correct string format. Next is the checkout IAC code stage. So a little bit about this stage. Now, our Packer template and the files are on a public GitHub repo. So when Jenkins runs this particular checkout step, it creates a workspace folder on the Jenkins agent VM that's running the job. And then it clones this repo to the local folder. So you have a local folder with all the files required. So all the subsequent stages work off of this local copy. Next, we initialize Packer to ensure all the plugins and dependencies are prepared. We validate the Packer template to ensure that the syntax and logic is correct for the template. And then finally, we build the AMIs with Packer. What this step is doing is it is spinning two EC2 instances, one for core, one for engine. It installs FME Flow using the provided installer URL. Once the installation is complete, it creates two new images or AMIs for the VMs, and it cleans up all the AWS resources, except the two AMIs, of course. Now, I do want to add here that as we see in this script, and as we will be going over the other scripts, there will be mandatory commands and stages like the Terraform commands or the Packer, the ones with the API calls, and the Flow CLI commands. We will also have stages that fall into the category of best practices. There are many ways to enhance these scripts to have other security and standard practices or take some of them out to keep it simple. So it's customizable to your IT policy. Now, for the test run of this Jenkins pipeline job, this one is for creating the AMI, but the pipeline elements are quite similar to the other pipelines we'll be looking at today. Okay. So we see the user parameters here, as was mentioned earlier: installer URL, owner, the build number, and the source AMI. And this is where the pipeline script goes. Now, during runtime, we provide the parameter values. And as we click build, we see the build running, the log entries on the console output. You see info about the agent running the job, the Git repo being cloned right here. There is Packer initialize command, Packer validate right here, Packer build command running as well. We'll see the Flow installer being downloaded and installed. We see PowerShell scripts running. And then it waits for the machine image to become ready. And then it cleans up the AWS resources. As we can see, there's a bit of deleting happening, but it does give us two AMIs, the two AMI IDs that will be stored on our AWS account. It takes about an hour to create two custom AMIs that will have Flow software installed, and that can be used in the next pipeline to spin up core and engine VMs. Which brings us to script number 2, which builds infrastructure on AWS for a fault-tolerant flow using Terraform. It supports 3 operations: Terraform plan, apply, and destroy. And it's using the custom AMIs created by the last pipeline. So the previous Packer operation is mandatory prerequisite for this process. So for this script, we start by building the agent. You're specifying the build agent here. We define constants like the working directory where the Terraform files are located, and then the AWS region where the resources might be created. And for user parameters that are provided value to during runtime, we allow the user to choose the Terraform action. So the user can choose between plan, apply, or destroy. And as the name suggests, it's basically related to what it does to the infrastructure on AWS. And we also provide the FME core and the engine AMI IDs that were created previously using Packer. So that's all provided during the build run. Moving on to the pipeline stages, similar to the previous pipeline, we are cloning the Terraform files from GitHub to the local workspace folder. We initialize the working directory, install required providers and modules. We validate the Terraform code to catch any syntax or configuration errors. Now, if the user selected plan or apply operation, it connects to our AWS account, plans the entire provisioning. The plan is saved to a file, and which may be used for the Terraform apply operation if the user chooses to apply the plan. If the user selected apply, it uses the saved plan file and provisions resources without a manual prompt. And if, of course, destroy was selected, this stage will tear down the associated infrastructure on AWS. It helps with a quick cleanup. Now, for our demo, we are focusing on the Terraform apply operation here, which will also be running the Terraform plan automatically. We have a very similar pipeline element to the previous pipeline. So we have choice parameters for the action, a couple of string parameters for the AMI, and finally the pipeline script. Now, during the job run, we provide the choice of operation. We're providing the two AMIs, trigger the build for the apply operation. And on the console output, we see Git related activity, Git repo related activity, Terraform initialize, Terraform validate, and there you go, the plan command is running here. It will then list all the resources that would be created by this plan. We're just speeding through this. But we see the plan will add 42 resources to the AWS account. And once it runs apply, right here, we will see a barrage of log entries for each AWS resource being created. So that's 42 resources, so it does take a bit of time. And after about an hour, we see 42 resources created. We also get the application load balancer endpoint to access our fault-tolerant Flow UI over HTTP. So including the previous back operation, that's all the time it took to spin up the resources for a complex setup, about 2 hours. So we are also reducing human error, improving reproducibility across environments. Of course, this is just a basic IEC template that Safe publishes, but having a Terraform expert in your team will further allow you to customize based on your requirement. Now, the third pipeline automates the first few tasks that are common post-deployment. So the first login, license request, adjusting the engine count, and a test job run, just to ensure that everything is on the up and up. As with the previous pipeline, we run this on the Jenkins agent node, and so we're declaring that here. Environment variables define paths for the FME Flow CLI binary installed on the agent VM. We also need a temporary file to save the admin login password, and another file for the API token generated after login. So we define all of that here. We also have 8 user parameters in this pipeline: the Flow Web UI URL, the number of standard and CPU engines required on the system, and then, of course, for the license, we need the user details and the serial number. So the first step is that the Jenkins logs into Flow using admin credentials and receives a token. All of this is done using FME Flow CLI command. We perform a system health check. It sends a license request with the user details and serial number, and then checks if the license request was approved. Now for engine provisioning, it loops through each standard engine VM created in the fault-tolerant install. So if you use the IAC template out of the box, it will be 2 VMs. Once it gets the standard engine count on the VMs, it adjusts both the standard and the CPU type engines based on whatever input we provided during runtime. And finally, it runs a sample workspace to confirm successful installation. Now let's look at the pipeline in action. On the Jenkins web UI, you see 8 string type parameters that the pipeline needs. So flow URL, user details for the license, so username and password, all the user details. And then here goes the pipeline script. Now, because we plan for this pipeline, we also perform an edit on the IAC template during the pack AMI creation. As you might already know, the first admin login after deployment will require password change, and that will cause issues with the pipeline. So we disable that. Right here, first login change password has been set to false. We provide the user input, 3 standard engines, 1 CPU engine, and run it. And on the console, output the Jenkins node successfully logs in as admin, as you can see here. And there is a health check. It requests for licensing. It's a health check right here. It requests for the licensing with all the user information provided. It confirms activation right here, successfully licensed. And then the engine counts are set. So it did scale, or sometimes it might be scaling down. And then finally, there's a successful job run. Now, we can add other supported flow operations and tasks via API calls or flow CLI commands as well. This is just the basics. The next step could be to run a backup and restore pipeline job on Jenkins to get a fully automated upgrade process. However, we are not demoing that today. Instead, we are going to be looking at a project migration next as our final pipeline example. So our last pipeline synchronizes FME Flow projects between 2 environments, like a dev and a prod install. We already have 2 express installations set up for this, but you can use any installation type. This job again runs on the Jenkins build server. We have a trigger configured with a daily cron job. Now this triggers the pipeline to run and look for projects updated or created in the source flow install in the last 24 hours. So this is essentially the brains of the trigger. We allow the user to choose the source and the target flow URL during runtime, because we're also allowing a manual run if it's required. So this option has been added in to be able to choose the source as well as the target flow. And we have some environment level variables like the temporary files to store login credentials to both the flow installs and for storing tokens after login. So our pipeline is scheduled, but it can also be triggered manually, as I mentioned earlier. So for better readability during the manual build runs, we use labels for the 2 flow URLs. One URL is named dev and the other is named prod. So as a first step in the pipeline, we map the labels dev or prod to its actual URLs. The build server logs into the source flow as the admin user. And this next step lists all the projects owned by the admin user. We're using flow CLI commands here. Then it compares the last updated timestamp to the current time. So if the project was updated within the last 24 hours, it downloads it to the Jenkins agent VM that's running the build. So it's just downloading it to the Jenkins agent. Next, it logs in to the target flow instance as the admin user. And for each updated project, it uploads the project file via a post API request, and then it executes a second post request to import the uploaded projects. So it's first uploading the project, and then it's importing them. Okay, so let's go over the pipeline. We have the Jenkins settings for the pipeline. We see the parameters, the two environment flow installs. In this case, prod and dev. Here is where we set up the cron job. And here we have the pipeline script. I do want to add here that please note to make sure that the encryption key is the same between the two flow instances. So I've gone ahead and I've made some changes and added some new projects to the dev installation. Now, when I look at the scheduled job log the next day, you see that there's a login to the dev server. It's checking for recently updated projects. In this case, there are 4 recently updated projects. So now that we have identified them, these are downloaded to, as you can see, this would be downloaded to the Jenkins agent. Next, we log into the prod installation. And all the projects are first uploaded, then imported. So there's an upload and then there's an import to the prod install. Now, if you want to trigger this manually, that would also be a possibility. So this feature is especially useful when deploying a flow object through the enterprise lifecycle, from development to testing to staging to production. And instead of backing up and restoring an entire flow configuration, you can simply export the project and import it to another flow. This way, the existing target flow configuration remains intact and the object is also migrated. If you would like to go through the pipeline scripts in detail, don't worry, we have published articles you can follow. And this brings us to the end of our demos, and I'm going to be inviting Dami back for closing thoughts.
Thank you very much, Melon, and for that demo and showing exactly how it works. So what are the other possibilities you can do with this? You can upgrade from an older version to a newer version of FME. You could also deploy Kubernetes installations. You could have more collaborative deployments with different users across different teams. And some of the best practices overall is your security. Make sure you have IAM roles. Make sure you have access keys rotated in your cloud system. Make sure you don't expose some of your secrets in your Jenkins outputs. So that's one of the major things we would like to ensure that users are paying mind to. You could also use a remote storage for your state files, which is like storing your Terraform state files in S3 or your Azure Blob storage. Could be not Google Drive, but could be the equivalent of what you would store in your GCP or an equivalent in Oracle, as long as it's in a system where it's not easily accessible to the public. And also scaling, you could also scale your Jenkins server if you wanted it to go a bit faster, HTTPS configuration to make sure you're propagating over secure routes. And yeah, other related information at the pages that we have for the Jenkins download, API, IAC, and yeah, we'll be very open to some of the ideas you have and how you can improve your CI/CD flow, and also just to see what a lot of you will be coming up with. And yeah, thank you very much. And if you have any questions for us, please let us know. Be more than happy to help. And we'll pass pass it up to Elizabeth now.
Awesome. Thanks, Dami. So just to quickly go over, if you are newer to us here at Safe Software, we've been in the data game for over 30 years across 25,000 organizations, working with over 200,000 users worldwide. We connect it all data velocities, locations, types, and any AI technology. FME is the only all data, any AI platform. All right, so just to take you through some resources, you're more than welcome to download the deck, apps, and then handouts in Livestorm, and you can toggle through these article links directly. But Merlin and Dami put together this page just with some helpful articles to help you get started after today's webinar. You can visit our FME Academy for guided learning at your fingertips, academy.safe.com, and I'll also highlight our webinars. We have quite a few that have just been posted recently, so check them out over at safe.com/webinars. In terms of next steps to take here today, we'd love to help you get started with anything data. Feel free to get in touch, info@safe.com. And our accelerator course, it is 90 minutes and free of charge. I'd encourage you to check it out if you're looking to learn the basics of FME. Claim your community badge. So if you are a member of our FME community and you like to redeem these badge codes, we do have the code on the screen here. I'll also leave it in the chat. But if you aren't a member of our community, we encourage you to take a look. It's a great place to both network with other users alike as well as FME experts.
All right, fantastic. And I'll invite our presenting team back on the stage here and we can take a look through questions together. We do have, about 10 minutes remaining here, so we can take a look through. Now's a good time to mention, if you do have any questions top of mind that you have yet to submit, please feel free to do that. Looks like we got a few great ones. I think we got to most of them, and some great feedback as well that we can take a look over together.
So we have two questions related to on-premise installations and how we could leverage CI/CD. As I mentioned in the answer there, of course, our IAC templates that we publish online on our GitHub public repo is more for AWS or Azure cloud providers, but we've had customers who created their own PowerShell scripts, and then they also introduced like best practices steps in there to maybe validate some of the steps that have been previously performed as the workflow goes through, and pretty robust PowerShell scripts can be created for installing, say, an Express installation, because I think that's the most commonly used installation type. So that can be done. And we have silent parameters for a silent installation that can be leveraged. And the post install steps can be performed using the CLI. And I also included the GitHub repo for our CLI options and commands that we have. So yeah, that is something that definitely can be done. Of course, it would require some scripting knowledge and some scripting background, but it can be done and it works. Yeah. Rami, did you want to add something based on your experience?
I think you pretty much covered it. Just to touch on some other questions there as well regarding use of the REST v3 APIs. So that's already been deprecated at this point, because I believe the question was in order to like use it. So it's going to be deprecated up until 2026, where it's to no longer be accessible. And that's with the release of FME Flow 2026.1, which should be released sometime next year. In the meantime, you can still use the v3 API. It's just currently unsupported at the moment, and it's been deprecated. And another question I was just getting to was if the setup is for advanced users generally. So overall, we usually would recommend, just going to answer that question here, usually would recommend users have experience with cloud and DevOps overall. In terms of the tools themselves, it can be interchanged with any equivalent. So Jenkins, you could use GitHub Actions, you could use Build Kites, you could use Bamboo. Any one of those tools, as long as they're serving the same purpose. You can interchange AWS with GCP. You can decide to use a different IAC overall. It's just the main concepts that really matter. So if you have cloud and DevOps experience, we have some articles just get you started on like how they work generally in this setup. But overall, we'll push more for if you have more experience to use this sort of deployment process.
And it looks like on a similar note, Joshua also provided a good tip in the chat there that he's enjoyed online training through Code Cloud for Jenkins, Terraform, etc. If that's of any interest to anyone. But yeah, good feedback.
Regarding the question from Hans, are you using predefined images from Marketplace or are you using pre-configured install runs? So we use the base images for the Packer run. So we use a base Windows image. I think I used 2022 version. So we use that image from AWS Marketplace and then install FME on it. And then it goes through the entire process of installing FME. And then once you have that, you create custom images with FME already installed on it. As I mentioned, one for engine, one for the core VM. And then you would, and then this is done using the Packer script itself. It would destroy all the AWS resources except the AMIs. And then that's what's used in the next pipeline for creating the AWS infrastructure. So when we get to the Terraform installation or Terraform script running, FME has already been installed on the images by that time. So yeah, that's the flow essentially. You need to run the Packer pipeline or script. You don't necessarily need to use Jenkins. You could just do it on the command line. But Jenkins obviously provides that reproducibility for multiple environments, so it helps with that. But it can be done and needs to be done with the Packer script.
And just to add a bit to that, generally in our case, or I would say in some cases that we've tested, we built the image using the IAC templates, at least from scratch, and then you can use like you add like the download link to choose like the version of FME you wanted installed, and once that image has been created, then you use that overall in your flow. Just give an overview.
Yeah.
Awesome. Okay, it looks like we've gotten to all the questions so far, unless there's one that I might be missing or another one we want to touch on, Merlin or Tammy?
Don't see any other questions.
Okay, awesome. Well, I will just note that if you do have a question that comes up, we will leave things running after we've wrapped up the webinar, at least till the top of the hour. So we'll keep an eye out and be sure to reply to anything we can there in the questions tab. But in the meantime, just a huge thank you to our audience for joining us today. We hope you enjoyed today's webinar. We really appreciate any feedback as well. If you have a moment to fill out our webinar survey, I believe it's just a couple multiple choice questions, and we really appreciate any feedback. It helps us improve our program. And big thank you to Merlin and Dami for all your time in preparing today's content and presenting. We really appreciate it. Thanks, everyone. Hope you have a great rest of your day. Bye
Thanks
for now.
joining.
Thank you so much for joining.